Scientists generally believe that extinction events occur approximately every 30 million years, with each differing significantly in its form, sheer scale, and the level of destruction involved. Sometimes disasters remain local and life manages to survive, while at other times the resulting damage is truly global. Fortunately, most of these events do not have lasting effects. Usually, nature recovers quite quickly, although that is certainly not always the case. Rarely, Earth faces a mass extinction, a catastrophe that changes the planet beyond recognition, defined as over 75% of species vanishing. Over the past 500 million years, 5 events met this standard, known as the Big Five. The deadliest of all was undoubtedly the Permian Triassic event, which has gained attention for its severity, but the most infamous one in history is certainly the Cretaceous Paleogene event, where a massive asteroid hit Earth, wiping out non-avian dinosaurs. Due to its iconic status, many mistakenly believe it was the worst extinction in history. However, that is simply not the case. It was not even the second worst event. The true runner-up is a forgotten disaster. Not only was it far more severe than the dinosaur extinction, it is the only event that rivals the Permian mass extinction. It was also the first of the 5 major extinctions, the late Ordovician mass extinction. To witness this, we must look back far earlier than the dinosaurs, past the Permian and Carboniferous, before trees even evolved. The Ordovician began roughly 486 million years ago. Earth was a true water world then, with land mostly as scattered islands. The oceans were vast, with sea levels potentially 2,000 to 2,600 meters higher than today. If that happened today, land would be mostly drowned. Surviving areas would remain constantly damp due to the hot, humid, rainy climate. Land hosted only early plants like liverworts or moss, barren and dull. But the oceans told a different story, teeming with an explosion of marine life. The creatures were bizarre, looking like aliens from another world. This was largely due to corals. These invertebrates had existed for ages, but only began constructing reefs during the Ordovician. They formed vast reefs globally, supporting unprecedented ecosystems that included a strange, extinct group of creatures known as nautiloids. Diverse and often huge, the shells of the largest Camaraoceras and Endoceras could reach 9 meters, with actual body lengths likely 10% longer. Speculations suggest the largest could exceed a ton. If true, they would be the first known animals to break that weight barrier. Equipped with powerful tentacles and sharp beaks designed to tear and crush most prey, they were likely the apex predators of that time, dwelling on the seabed or actively hunting in the deep ocean. Back in that era, there was a very common creature called the trilobite. You might not know them well, but you should, for even if they weren't scary, they were one of Earth's most successful animals. Though they lived hundreds of millions of years ago, over 22,000 species are known today. This shows their shapes and sizes were endlessly varied, adapting to countless niches. Some even learned to make occasional trips onto land. Found in almost every environment globally, they were ubiquitous. This meant many predators ate them, including the recently emerged sea scorpions, scientifically known as eurypterids. One look at their structure tells you they were lethal, yet they were also diverse. Some had limbs for digging, others for grasping or tearing prey. Their tails varied too. Some were paddle-shaped for swimming, while others developed a spine, non-venomous, but capable of repeated stabbing. But at that time, successful as they were, they hadn't reached their peak yet. That era would arrive with the Silurian. Therefore, most eurypterids back then were small, but naturally there were exceptions. Giant human-sized species existed, and they were most likely the apex predators of the time. We found food remains in their coprolites, including jawless fish, trilobites, and even other sea scorpions, making them the earliest known cannibals. It is one of the animals that could be called a trendsetter. If you think that is weird enough, then you have to see this enigmatic creature, Anomalocaris. These creatures were essentially elite-level predators, boasting massive compound eyes and a mouthpart that looks like the source of pure psychological terror. After studying them, scientists believe this mouthpart might have possessed the sharpest teeth on Earth, measuring only 1/20th the width of a human hair, likely scraping prey like modern hagfish or lampreys. Truly a creature straight out of a nightmare. Even worse, they didn't just live in the deep, but roamed every level of the ocean, meaning there was nowhere to hide. And the grand finale of this bizarre world is the radiolarian, looking exactly like aliens from a sci-fi movie. Radiodonts were exceptionally diverse. If you can imagine a killing method, there was likely a species among them that actually used it. They included active predators, sediment sifters, suspension feeders, and filter feeders. The most astonishing was Egurocassis, a giant radiodont, larger than most humans, that once lived along the coast of present-day Morocco. Without a doubt, that was a truly alien Earth. But this weirdness wasn't limited to marine life. On land, day or night, if you looked up, you might see Earth's ring. Yes, a ring just like Saturn's. Scientists noticed that certain geological strata are rich in L-chondrites. This implies that about 500 million years ago, a massive celestial body was torn apart by Earth's gravity, forming a ring around the planet and leading to a distinct period of time that is widely known to scientists as the Ordovician meteor event. This period lasted 40 million years, with a meteorite impact rate 100 times that of today. Countless meteors streaked across the night sky, rings hung high above a boundless ocean, and everything possessed a metallic and visual grandeur. But it all finally ended about 445 million years ago in one of the Big Five extinction events, the late Ordovician Mass Extinction. It was a massive disaster with causes still debated. The mainstream view is that Earth entered an extreme glacial period. The surface darkened and global temperatures plummeted while sea levels dropped. The Qatar Ice Age event formed ice sheets across vast areas of Africa, South America, and North America, reaching 250 million cubic kilometers of ice, 10 times the volume of today's Antarctic ice sheet. Ice sheets currently store about 61% of global fresh water. Scientists believe this prehistoric freeze was totally different from the ice age experienced by humans and mammoths, as global temperatures likely plunged by more than 8 degrees Celsius. In other words, if you lived in New York, it would instantly become like living in Iceland, but even worse. This rapid cooling froze countless animals, causing violent climate fluctuations and ecosystem collapse. The situation was particularly dire for shallow water life because as ice sheets expanded, sea levels dropped sharply, wiping out habitats and destroying vast coral reefs and their ecosystems. At the worst point, sea levels fell by over 125 meters, or about 410 feet. If this happened today, the face of the Earth would change drastically. Even worse, as waters receded, exposed seabeds revealed rocks and minerals that absorbed massive amounts of CO2, further intensifying global cooling and driving further extinctions. The suffering and ruin weren't quick, like ripping off a band-aid, but like tearing it off and sticking it back repeatedly. A continuous, agonizing torture. This ice age may have lasted 35 million years, longer than some entire geological eras. Many species were devastated in the first wave of this catastrophe, including brachiopods, graptolites, trilobites, and bivalves. Strangely, while shallow seas mostly dried into land, deep-sea life seemed to suffer even more. Some paleontologists believe it was a global toxic event, where ocean oxygen levels dropped too low for cells to survive, causing mass die-offs. Other hypotheses suggest that, before the Ice Age began, or even midway through, an anomalous short-term warming spike may have also triggered this disaster. While small organisms suffered the most during this catastrophe, large creatures were not spared either. For instance, various swimming cephalopods and nautiloids went extinct, and radiolarian populations plummeted. But as Jurassic Park's Dr. Ian Malcolm said, life finds a way. And indeed it did. Life didn't just survive, it expanded. Two brand new groups emerged, better adapted to the frigid waters. Collectively, they are known as the Hernantian fauna. Despite this small victory, life was still struggling through these painful times. And reality may have been far worse than just a simple case of bad weather. As studies suggest, with oxygen depleting, toxic metals, specifically high levels of mercury, began seeping into the seabed, devastating organisms at the base of the food chain, ultimately causing the collapse of the entire food web. For any animal, this nightmare couldn't end soon enough. Yet, ironically, when the Ice Age finally did end, it somehow triggered a new catastrophe. Unlike the first, this is classified as the second pulse. It turns out, even when you get used to something, even something bad, you still feel a shock the very moment it finally disappears. Like the first extinction, the end of this Ice Age is shrouded in mystery. The prevailing view is that around 420 million years ago, the cold snap ended abruptly, collapsing the Ice Age. This may have been a victim of its own success. As previously mentioned, the ice sheets were unimaginably vast, exceeding anything in the Phanerozoic eon. Due to their sheer volume and crushing weight, like a giant house of cards, they finally collapsed under their own weight, sliding into the ocean. This caused rapid sea level rise, triggering drastic global warming. It was a rude awakening for all the creatures adapted to the cold shallows. Even worse, as the ice sheets vanished, they likely flushed massive amounts of nutrients back into the system. Combined with increased sunlight, this sparked massive algal blooms that blanketed vast stretches of the ocean. This tragedy killed many of the remaining animals. Between the rise and fall of the Hernantian glaciation, Earth was ravaged. When the dust finally settled, very few living things managed to survive. Ultimately, 49 to 60% of marine genera were wiped out. Since most life was aquatic, half of all life vanished. The list included a third of brachiopod and graptolite families, plus many corals and trilobites, the latter losing 50% of their families. Even despite their immense resilience, they would never be able to fully recover. The massive Camarasaurus that once ruled the seas were certainly not spared. This event marked the final end of their long reign, the very last time the world would see them as apex predators. Generally speaking, though, they still managed to maintain some numbers. In stark contrast, scorpions fared much better, as they successfully retained the majority of their biodiversity and rapidly expanded into this empty world, becoming one of the most dominant animals of the Silurian. Another comeback story is the crustaceans. They lost nearly 70% of their genera in the Ordovician extinction, yet they defied the odds, thriving in the new tropical shallow seas of the early Silurian, bouncing back in no time. Unfortunately, not all creatures could pull off such a miraculous recovery. Take brachiopods, for instance. To say they suffered heavy losses would be an understatement. Once incredibly diverse and abundant, they were drastically reduced. Most species perished, leaving very few survivors. Even among the species that survived, many exhibited the island effect. As proof of their suffering, many modern brachiopod groups haven't regained their former glory even after 500 million years. Truly ill-fated. Others, like corals, were somewhere in the middle. They eventually recovered, but it took ages, an entire geological period, only regaining diversity in the Devonian. Fish were similar. Though neither dominant nor diverse at the time, they were also impacted. It didn't truly flourish again until the Devonian period. Clearly, this extinction plunged the Earth into an extremely dire state. Of the 5 mass extinctions, one ranks first in the severity of permanent loss in a key area, despite not losing the highest number of marine families. Yet its extinction rate hit 87%, while the Great Dying was only about 81%. Moreover, research finds this extinction might have been even more tragic. At its peak, life dropped like flies, dying even faster than at the end of the Permian. It took nature at least 5 million years to recover from this nightmare, or possibly up to 20 million. This means entire species, genera, and families rose and fell in this post-apocalyptic world. Which leads to our final question. Where exactly did such a massive ice age come from? No definitive answer exists, but scholars propose several hypotheses. The most direct guess involves tectonic positioning. During the Ordovician, most of Earth's land was located much further south than it is today. Plates kept pushing toward the South Pole, causing a deep freeze. But considering the ice age formed rapidly while plates moved slowly, scholars think geology alone can't explain this. The most dramatic guess: a supernova or gamma-ray burst, a theory from the early 2000s. A gamma-ray burst 6,000 light-years away might be the true culprit of the first mass extinction. This 10-second burst hit Earth, destroying the ozone layer and causing oxygen to react with nitrogen. However, support for this view is low, and it's recently been replaced by other hypotheses. The most striking theory involves a massive asteroid impact. In 2023, researchers in Australia found a deep buried ring structure, a suspected asteroid impact site. If true, it spans 520 kilometers, nearly 3 times the size of the asteroid that killed the dinosaurs. An impact of this scale would not only wipe out life directly, but could easily trigger a global ice age. But the team stresses this needs verification. The most popular hypothesis is volcanic activity. Volcanoes usually release greenhouse gases, causing warming, but the late Ordovician might be the opposite. Massive sulfide releases from eruptions plunged Earth into a cold spell. But some scholars argue the initial brief warming from the eruption was the fatal killer. Other fringe theories include shadows from Earth rings, or land plants booming and causing a CO2 crash. The debate might last years, but one thing is certain. If you were any creature then, even a tiny single-celled life, you wouldn't want to live through this disaster.